I'm sure most of us would have already had some kind of an understanding in terms of what is a natural language processing and the computer vision as such. I will quickly go through some of the use cases in terms of NLP, and the agenda that I have put forth is something like this, where we will start with introduction of the NLP and what is the journey towards transformer, and what is the transformers architecture, and we will introduce that, and how we are going to utilize some of the frameworks which are available in the market to actually demo NLP using transformers. And then we will quickly look at computer vision and how transformers are actually helping on the computer vision perspective. So that is the whole focus on today's session. So I'm sure we are all familiar with some of the use cases in terms of natural language processing. So couple of services, for example, translation service. If you are speaking in one language, you go and visit some other country, you do not understand the language, you can utilize the translation service to basically understand what is going on there. So the translation service is an excellent example of how NLP is making a stride in the whole process. And I'm sure we are all familiar with personal assistants in terms of Alexa devices and the Google assistants that we use. And you can speak to these devices. They are not just the music players, but also can understand your language and process that language and translate that and provide you the response and so on and so forth, which is kind of an extension of your in terms of your chatbotting solutions and so on and so forth. Even chatbot can also be attributed towards natural language processing solutions there. Um, so the next is in terms of text generation. So there could be cases where you have a certain text that is available and you wanted to see what kind of a text that gets generated out of the initial text that you have created. You have various tweets. You are working on a large company, and your company is releasing a new product, and you wanted to understand how the people are reviewing that particular product, and is there any negative sentiment, is there any positive sentiment towards that particular product. All this information you can understand by using something called sentiment analysis. Majority of the use cases that we are going to look at, that I have presented here, we will have a demo of the session, whatever is possible. A summarization, I'm sure most of us might have utilized some of the short summary of news applications. There are applications like shorts and so on and so forth. They utilize NLP in a very big way in terms of you have 4 or 5 pages of an article, and you have to basically summarize this particular article and provide the article in a very crisp and small paragraph way. And you can actually define how much of a summarization that you wanted to do, and what kind of activity that you wanted to do as part of the summarization as such. Text classification in terms of so I have a text, what class of information this particular text is talking about. Is it a business specific information? Is it specific to an education specific detail, or is it a medical related information? You may have to classify a specific text. It could be a conversation between a doctor and a patient. It could be a conversation between an insurance agent and a potential customer. Many of these were utilized heavily in the call centers and BPO operations and so on and so forth. Just text classification plays a very major role in those areas. And question answering systems. Chatbots can also be thought of question answering system, but there are special cases like in terms of questions generation itself. From an education perspective, you have lessons which are available, and these lessons typically your teachers might be creating the questions and setting up the questions for your exams and tests and so on and so forth. how can we utilize the NLP actually to do the automated questions generation and also question answering systems where you ask some question specific to the context that you have given, and based on which the NLP system will understand, and whatever question that you ask specific to the context, it can actually respond back with the details. So these are some of the use cases in terms of natural language processing, which are pretty common in the industry. I just wanted to, have this session as a very interactive session. I wanted to understand any other use cases that you think would be part of natural language processing. I would request you guys, what do you think is the one use case that you have already used or you'll be using it, you like it, and or you see any other use case that you think which is not listed here. I would request you guys to utilize the chat window to just share it across, or you wanted to unmute and speak it across. We would like to be an interactive session. So I just a question: which one is the one that you have used or you are utilizing part of your company or anything, or you have done? I'm sure majority of us might have come across something like assistant, Google Assistants, if you are using Android phones and all. If you're using iOS devices, then you might be familiar with Siri based interactions and so on and so forth, right? So yeah, so there are some chats came. Yeah, Siri. Yes, from an iOS users, Siri is a very prominent platform for you to actually utilize for interaction uh, with the with the iOS devices,
As
right?
part of our applications, Prasanna, we are
Hmm.
trying to implement almost like a chatbot, but where we are using NLP is kind, you can either enter a text, you can ask
Okay,
for a question for the bank people,
okay,
where otherwise you can also speak with that. It
wonderful.
can be any voice assistant, it can be Android or iOS. That text will be converted later into speech to text, and then it will process with NLP to understand user context what he is trying to ask based on previous his chat. Then we'll try to reply the
Okay,
right result to the user, where it is like a more or interaction kind of a session rather than I am asking the question only system is replying pre-feeded data, not like this.
okay, got
That's
it,
why we are
got it.
trying in the current applications.
Wonderful, wonderful. That's a very very valid use case. Any other use cases? Okay, so now let's come to the basics. Okay, so let's think in terms of, we all as a human being, we think in terms of details on text, images, and so on and so forth. So we are all conversing in this language, in English, so you all able to understand the language. But if you look at typical computers, they do not have the capacity and capability to actually understand the language as such. So the basic premise of an NLP, how can we address this scenario in terms of, let's say I wanted to build a chatbot, but my system does not understand English as such, right? So what are all the different approaches that with which I can have a chatbot being built from a base level? Any thoughts? Let me repeat the question. So I want to build a chatbot solution. So the chatbot solution, I could be asking any kind of questions. So my machine should actually understand that question and actually provide a response. That's a typical chatbot solution required. Now, in a typical human conversations, because we all understand the language, we can think in terms of the language that we are in conversing. So in the case of English, I speak in English, you can understand English and you can respond back in English. But that is not true in terms of machines. And how can we actually make the machines to understand what we are trying to do? I could be explaining the same statement in a multiple different way, like what Malli was talking about in terms of bank-based transaction in a chatbot. I could be talking to the chatbot in for the same activity that I wish to perform in a multiple different way. One example could be that I could be telling that I wanted to transfer $10 from XYZ account to my account. Or the same statement I could tell that transfer from XYZ account $10 to my account. So both the statement basically communicates exactly the same outcome, but it has the words and the details are being shuffled in a multiple way. So how can we actually address this? Any thoughts? You can even unmute and speak. Any thoughts? So now here the scenario where we have a chatbot and where we are going to use for say banking, where it should respond to me based on whatever the request that I'm giving. And for a transfer of money from one account to another account, I can be telling the chatbot in multiple different ways. How can we make the actual system understand what I'm talking about? Any thoughts? Okay, that is the basic premise of your natural language processing. Let's
I think,
get that. Yeah.
yeah. So the
What?
keywords what our suggestion is given, finding the context what user is trying to take, finding that somehow.
Wonderful. Yeah. Important keywords. Sankesh was telling important keywords. And Malik, context is fantastic. I'm going to the next level in terms of the first basic thing that you have in your point is valid. Context is what our goal. But before the context, representation of your English language or whatever may be the language that you are looking at for your natural language processing, there should be a representation, representation should be there. Okay, but if you look at computers, they not cannot cannot understand, cannot process text. So there should be a way of representing your language into a textual the textual language into a numerical form, so that once you have a numerical representation, computers can understand about it. So the process of representing your textual content in a numerical form in natural language processing, it is called embeddings. Okay, so the embedding is not a big thing in terms, let's say you have a paragraph. The paragraph might be having multiple different words, and instead of we representing this particular paragraph, you will be representing this each and every word in the paragraph as a matrix. Effectively, you will be representing them as a vector. That is what is called embedding. Typically it is called embedding vector. So this is the basic premise, the basic building block of all the NLP system. Yes, the context will come, we will touch the context in a minute. Okay, so for the last I would say many years, more than a decade, word to vec was one of the biggest embedding vector which was in the market. It had They've already taken pretty much all that you can think of in the English language, all the words. They have mapped it into a vector representation by using this word to vec. Okay, this is the first premise. Let's keep continue our understanding in terms of what is this word to vec and how does it work. For example, here let's say you have this animation actually talks about how the embedding vector is getting created. Let me just use the pen. Let's say I have a word, I saw a cat. Okay, even the full stop is available here. Okay, each and every item that you have on your text is an important item when it comes to a conversation. So we computers cannot understand this. I saw a cat with a full stop. Computers cannot understand. So what you have to do is you have to basically tokenize each and every word. So for example, I is tokenized with a representation here in the embedding vector, so the I is represented in 39th position, saw is 1592's position, a at 10th position, cat at so and so position, even the dot has a position of 5. Okay, so this whole embedding vector is going to be the size of this is equivalent to the vocabulary size. That means you have millions of vocabulary in your language, then this embedding vector will have that million dimension. So this is the first basic representation of your information in the natural language processing way. So this is what word2vec does. Word2vec basically does the process of taking and mapping each and every word into a vector representation. It will give you a vector representation. Okay, so I did it. But let's look at the problem. You were exactly talking about the context, Mali. So that is where I'm coming. Not just English, but you take any language, there are so many words which basically has different meaning based on the position it was available. For example, you have a sentence like he didn't receive fair treatment. A word called fair is being used, and when you process this particular statement using, let's say, word to vec, what it'll do is it'll take this fare, and for this fare it will provide a position in the actual word embedding space. Now the actual meaning of this statement is somebody did not receive a fair treatment. But if you take the same word fair in a different context, here, a fun fair in Chennai city this season. So now here the fair that you are seeing here has a completely different meaning here. But as a word to vect doesn't differentiate based on the context, it takes the word, an equivalent word which is available there in the, it will map it with the actual embedding space, and it will not bother what is the context in which actually that particular word is being talked about. And in many cases, if you are looking at translation surveys, this is a big problem, because you wanted to say translate this from English to Telugu or English to French or some other language, the complete meaning of your translation goes for a toss. So effectively, the context we should take care of it. But the word to vec currently does not support it. Okay. So we will come back to this. How do we solve this problem in a minute? So the next thing is looking at the existing architectures that are available in the market and how these architectures currently help solve the natural language problem. So I assume that you all have some background of something called a neural networks. These neural networks are some of the latest development in the last decade on how we can actually solve a lot of complex problems. One form of a neural network called a recurrent neural network, which was specially used for your natural language processing jobs. Let's understand from this diagram how this recurrent neural network actually works. Now, in the case of RNN, it's called RNN. So, how it works is, assuming this is an RNN, so it takes each time step. This is called time step. It will take each time step and it will process sequentially the information which is going to come into the RNN. For example, what time is it? Question mark. This is a statement that he wanted to process using the RNN. How will it process? On the first time step, it will take what, and it will process, it will understand. And in the next time step, second time step, whatever it has processed, it will send it to the second time step. Along with this, it will also take the second item. So now, because it has the second step not just consist of the new item, the time, it also consists of what it has processed already, what. So this will have, it will understand much better in terms of what is that it is currently processing and what it has already processed. Likewise, it will do the time step 3, 4, 5. You have a big paragraph of the text, it will process that in a sequential manner. So this is the way in which the recurrent neural network actually work. There are a couple of variances of it, whatever that I have mentioned. There are a couple of variances of the neural network, and one variance of it is especially for translation services. So the translation services, how you do is you may require two different pieces of a translate to actually implement the translation service. One is called encoders, another one is called decoders. So you will have a different set of encoder recurrent neural networks and decoder recurrent neural networks. What happens in the encoder is when you have a sentence that you wanted to translate, the encoder recurrent neural network will sequentially first process the input data, and it will understand the complete end to end of your actual language or the sentence that you wanted to process. And once it have processed the details from the input, it will then transfer the details to the decoder part of it. Encoder basically understand the input, and the decoder basically does the actual conversion of the mapped value to the corresponding translated outcome. So the encoder and decoder format is the recurrent neural network's approach to your translation service. Okay, and there are certain problems in this in terms of how much of the data that you can actually refer back. Now here in this example, I have only 4 words, and these 4 words that you are translating using this encoder decoder architecture. Now assuming that you have a large a part of your Wikipedia surveys that might be having in terms of a huge corpus of the data, and you may not possibly be able to utilize RNNs. So that's where they have introduced something called LSTM and GRUs. LSTM stands for effectively long short term memory, and GRU is graded recurrent unit, and so on and so forth. So these were some of the variances of the recurrent neural networks to actually perform any natural language processing operations. Could be translator, translation or text generation, text processing, summarization. All can be done by using these neural networks. Let's look at what kind of a problem that you face in terms of this. Assuming that you have a statement like this: as alien entered our planet and began to colonize Earth, a certain group of uh, extraterrestrial, there are some more informations are being available there. Okay, so assuming that there are two set of information here, assuming that you are going to provide this as an input, you are going to work on a text generation use case. You are going to give this as an input to your NLP, and you want the NLP to actually generate this or understand and generate this. To actually the NLP to actually understand your framework, to actually understand and generate, it has to basically have a connection with the previous the statement that is being there. For example, the extraterrestrial has a very good connection. It has to understand that it is aliens that it is going to generate. Specific to aliens, it has to generate the text. So it has a connection with aliens, and the group basically also has a connection with aliens. And not just there, for example, Earth has a connection with planet. So these are some of the connections. Once your system, the framework that you are utilizing, it should, or the approach that you are utilizing, should have the capacity to understand what is being input. It should remember what is being the input, so that it can actually understand it and process this. Human beings are pretty straightforward. They can actually, if you tell a statement as aliens entered our planet, just fill this particular statement, you complete this, they remember that the aliens entered our planet is the question that is given to me, or based on which I need to generate some statement. So you talk about Earth, extraterrestrial, and so on and so forth. But we have to make the machine learning or your system to actually learn about it and process about it. Okay. So we talked about the recurrent neural networks, LSTM, GRUs, all these things, or these natural language processing solution. One of the basic problem is in terms of they don't have a large space. When you give large amount of information, they cannot go and refer to the items which are at the beginning of your statements. Here in this case, RNNs cannot go beyond a referencing window that is being said. So the referencing window you can actually have to a certain number of characters or the statements part of the referencing window. It cannot have an infinite size of a referencing window. That's a big problem. So now when you are trying to generate the text, because your referencing window is only up to this, you may be the algorithm might be thinking only the statement specific to this. It may not even talk about or take the consideration of aliens. That's a big problem. So we'll see how we will solve these things in a short while. Okay. So in 2017, so whatever that we were talking about, RNNs were there for quite some time, at least a decade old frameworks and solutions. And if you look at in 2017, they thought through all this problem, and they Google research have introduced a research paper called "Attention is All You Need." So this 2017 December paper was the basic building block for the transformer architecture. So in this paper, they've done a detailed research, they've done an experiment and detailed how they achieved it and what is the actual architecture of the transformers. That is what is introduced in this particular paper. So, so now here, how do we solve the problems that we talked about it, and how transformer talks, solves that one? In the case of context information, the encoding information should, in the paper, they have introduced the context based and positional information based will also be utilized for building the embedding layer. That means the same example that we looked at in terms of he didn't receive a fair treatment and fun fair in Chennai, these two fair will not be considered as the same one. For this pair, you will be receiving a different embedding vector, and this pair, you will be receiving a different embedding vector. Hope it makes sense. Okay. So here, this pair, it could be telling that it not just has the embedding vector talks about the context, but also it takes care of the positional information. So what is the previous one, what is the next not the next one, the previous one, and the previous one. That positional information is very much included as part of your actual machine learning process. So that is the difference between that this contextual information actually solves the problem that we were talking about, contextual and positional information. The second problem that we were talking about is the referencing. The actual transformer brought in a concept called attention mechanism. This attention mechanism has an infinite referencing window, meaning you can have the whole text to be part of your reference. As you are having a large text for your referencing, you do not need to worry about what is going to happen if you lose the context as such. You will still have the context, you will understand the algorithm will understand and actually try to provide the actual response for you. So these two problems are solved by using transformers. I hope it is clear how we are setting the base for the transformers as such, right? Any question, team, friends? Any questions till now? Okay, I take that as a no. So now let's look at how the transformer work. So it works typical RNN how you looked at it is a similar way, but the architecture of the transformer is much complex. You have some input and you need some output. You basically put forth that the input to the transformer will spit out the output. It could be whatever the scenario that you have, that you should be able to conform it. And it also follows the similar structure that we talked about in the RNN translation surveys. The transformer consists of encoders and decoders. And these encoders and decoders help you actually do the natural language processing work. Let's dig deeper based on the architecture that is being shared from Google. So this is the architecture that is used for the transformers as such. So it's a pretty complex one. So we don't need to bother about. There is a lot of mathematics behind what is going on behind the screen and so on and so forth. And mathematics is very complex. We'll look at from a programming point of view shortly. Okay, so how do we utilize, how do we build, and so on and so forth. Okay, effectively this is the input data that gets embedded. This is embedding part of it in terms of encoder part of it, and this part is basically a decoder part of it. This part is the decoder part of it. And they brought in something called attention network, and they have this input embedding that all consist of not just the information about the embedding vector, but also the position and the context informations all are being included as part of your embedding as such. The attention and this embedding were the major differentiator for your whole transformer architecture. What is this attention that we're talking about? Let's have a look at some example before we go there. Typically, what are all the different pieces that we have part of the architecture? Let's look at it. So we talked about the self attention, the attention network, attention encoder, and you have this feed forward network. Those who know the neural network, that feed forward is the first flow of from the source to the destination, that's called feed forward network, and the same similar network are being utilized here. And the other side of it is called decoders. There is the self attention at the encoder end and the self attention at the decoder end. Okay, and you basically have these details being done through feed forward network, and this is the architecture that they've shared as part of Google's outcome as such. So now, what is the self attention talked about? For example, if a specific word in a statement is there, and not just that word, but a context information about that word will also be considered or created with the encoded matrix, encoded vector. The context information in terms of, for example, I kicked the ball. The kicked, if you take the word, who kicked the ball, that is a context, and I kicked it. And what is the activity that he did? He did a kicking, and to whom? It is a ball that he kicked. So all these informations are coded as an encoding as part of create the attention vector that is getting created there. Okay, so I hope it is clear in terms of how the self attention actually works there. You basically understand the fact that the actual self attention and uh, the actual feed forward, the new architecture, encoder decoder architecture, basically help build the transformer for uh, the NLP activities. Okay, so let's look at how the NLP models have evolved. In the case of the initial NLP things were available from 1950s. The bag of words were some of the initial set of NLP algorithms that were used. From there, we have something called TF-IDF, term frequency inverse document frequencies algorithms, and co-occurrence matrix have come. And in the recent past, we have this word to wake Glowy algorithms were pretty popular in terms of creating the embedding. And in the recent past, we have from 2017-18 onwards, we have transformers were doing extremely well. If you are an NLP developer, you should have end-to-end understanding of transformers. Little variances on the transformer model where the BERT, Elmo, XLNet, and so on. There are a lot of other variances are available. These are tweaking of the same paper that attention is all we need, and they are little modification in terms of transformer architecture as such. The BERT is one of the recently popular one. So bidirectional encoder representation for transformers. Elmo is nothing but embedding for language from language models. So these are some of the frameworks that are being recently done and being utilized. And um, from the Google, what they've mentioned is, I'm not sure you've noticed in the last couple of years, the Google search and many of the algorithms that are being used in the Google, they have utilized transformers. Because of that, the actual response from the Google search and the correctness of the Google search has improved manifold, because Google can understand the customer's request much better. Because they can understand the contextual information much better, they can actually provide the response in a much better way. As per Google, they have already integrated the transformers as part of their many of the services, including the Google search as well. Okay, so now let's look at uh, how they have built in the transformer world. There are so many different variances of frameworks or language models have come up, and these language models enable you to utilize the pre-trained language models for many of your natural language processing tasks. The recent one delivered by OpenAI, that is called GPT-3, and the amount of data that they have used for processing that particular GPT-3, you can see the number of tokens that have been used. Tokens, you can say it's like an embedding vector. The number of embedding vectors, that is the size of that embedding vector that they have used for processing, it is pretty much mind boggling. At this point in time, GPT-3 is a variety of transformer language model which is at par with a human level of understanding, human level of response that it can provide as such. That's a beauty of it, because of the amount of processing that they've done with the uh, actual GPT-3 as such. So let's look at how do we experience this transformers as such. So one approach is the complex architecture that I was just showing to you guys. You can write your own code in terms of translating that architecture into a code part and start working on it. The other approach is, there has been framework available that can help you actually utilize these frameworks for your actual execution as such. So you don't need to worry about much in terms of utilizing. You don't need to code the transformers as such, but you can utilize something which is already being built for your natural language processing activities as such. One of the beautiful framework that was company and the framework that is available is Hugging Faces. And Hugging Faces have built a wonderful platform in terms of their own transformer architecture, but also has an option of utilizing. They created a marketplace where people can actually start building code for the transformers and have it uploaded to the marketplace, and that marketplace transformers can be utilized for your specific activity. For example, let's say you wanted to have a translation engine from English to France, or English to Germany, and Hugging Faces might not have the resource and the actual people to actually do the actual translation work, because you need to create the embedding space and actually train your model and have it deployed there. So what they've done is they've made it as a community engagement, and in the marketplace it's called Hugging Faces Hub, where you can actually uh, create something and put it there so that people can actually utilize that for their own execution and so on and so forth. Right now, if you look at, there are more than 40,000 plus models are available there, which are being built by the community for anyone to utilize. It's all like free models which are available for you to directly utilize. Now, part of the whole process, they split the whole thing into transformer implementation into two parts. One is a pipeline, and the second one is the model. On any transformer thing that you looked at, there is first is a pipeline, and the second is the model that you use for your implementation. The pipeline is mainly to actually process your input data and convert the data to a specific activity that you wanted to do. It's basically to tokenize your data into an embedding space. That is what is done in the pipeline activity. And the model basically talks about what kind of a problem that you are trying to solve. And you could be solving a text generation, could be solving a translation activity, and so on and so forth. And the combination of these two basically help you solve the specific natural language processing task. And you can even take the existing pipeline, existing model, you can customize it, and you can have your own workflow in place specific to your problem statement that you are doing there. Okay, so that is the introduction of Hugging Faces. Now let's take you to the live demo of some of the interesting use cases that we have seen in terms of sentiment analysis, translation, text generation, summarization, text classification, and question answering. These are some of the use cases that we're going to see on today's session live demo. I've already shared the GitHub link where I've uploaded the code. All the code that I'm going to demonstrate were all already available in the Hugging Faces repository, and you can enjoy the actual demonstration there. I'm just switching to the demonstration. Okay, let me increase the font. I hope all are able to see the screen that I have shared now.
Yes, Prasanna, we can see you.
Wonderful. So what the way in which I'm going to demonstrate is, I have taken the Google Colab, and the code that I have already shared it in the GitHub as an IPython notebook, and you can actually download it and start utilizing it. And I just noted that the actual instance was disconnected, so all that I have done previously might have been lost. So I may have to rerun it. So the first step is in terms of installing your transformers and the related data set. So a simple line pip install transformers will help you install the transformers on your environment. Currently I'm using the Google Colab. In the Google Colab environment, I'm getting the transformers and the related data sets being installed. It is installed successfully. Let me start talking about each use cases. So to utilize the Hugging Faces, you have pipeline and the model. There are two things. And if you know only the pipeline, you don't know which model to utilize. There could be thousands of models which are available from various vendors. You can leave that model selection to Hugging Faces. It can actually identify the best model that can fit for a specific problem that you are trying to solve. Now, in the case of first item, it is a sentiment analysis. Sentiment analysis in terms of, let's say, we are all familiar with tweets. Uh, you watch a movie and you post that the movie is very good or the movie is very bad. Effectively, the actual movie producer, if he wants to understand what is the overall sentiment of large audience, what he can do is he can take all the tweets that are coming up, and he can put forth that to the sentiment analysis process and understand overall what is the sentiment of the actual comments that are being provided from the users as such. I'm just getting the reference of the sentiment analysis pipeline, and I'm just putting it in some variable here. Here if you look at, it is clearly saying that there is no model was applied. I did not mention what is a model to utilize. I just mentioned I'm creating a pipeline with sentiment analysis. Because I have not mentioned it, it is taking the default model, which is the sentiment analysis model. It automatically downloads it to me. Now this classifier variable, very simply in 2 lines of code you can start utilizing this. I can provide some input and say what is the response. I can run this, it will say based on which this particular statement is a positive uh, positive sentiment. And similarly the same classifier, I give a different statement and it gives a negative review. Okay, I can even change this. The NLP session is fantastic. Okay, run it, and it provides that the response as positive with a score of 0.99 percentage as such. That's in terms of sentiment analysis. The next is in we might want to have multiple data to be passed on, so that we wanted to understand what is the status of the whole pipeline as such. Okay, so here in this case I can set this as an array of input. Instead of calling each and every time, I can have a bunch of reviews that I received as a tweet. I can create a single array with as much rows as I want all the information. You can actually do processing individually and provide the response. Let me run it. So when I run it, it automatically takes each and every row or each and every item in that particular information, process it and provides the details there. Let me change this one. The NLP session is fantastic. Now when I run, both output will change it to positive as such. So it's very simple way for utilizing using your NLP. In couple of lines of code, you will be able to achieve the sentiment analysis. In the background, what is happening is the information that you have shared, the framework takes it and tokenizes it and applies all the item that we looked at, self attention and your encoder decoder, all that is being done in the time that you're talking about, and it processes it and provides the corresponding sentiment as part of the softmax layer at the end. Here the beauty of transformer compared to RNN is the transformer works in a parallel way rather than how RNN works in a serial way. If I have this statement, if I am processing it with RNN, only one word will be taken up at a specific time step. So for each time step, only one word will be taken up in a sequential way and it will be processed. But in the case of transformers, all the complete statement will be sent to the transformer in parallel, and the processing of all the words will happen in parallel because you are forming the positional information and the context information for your statement before you actually process it in the transformer. Because this positional and the context information is included part of your input, you even if you shuffle your text, because the positional vector is already created, that will not cause much of a problem. You will get a beautiful output as it is coming. What I mean by shuffling is you can even shuffle this statement like fantastic session NLP. In English word, it might not be giving you proper outcome. But once that embedding vector is created, even if you shuffle this after creation of the embedding vectors, there is absolutely no problem in that. It will automatically process and provide the proper response for you. That is sentiment analysis. The next item we're going to look at is in the case of text generation. Text generation were very innovative use case in terms of what can be done. We were talking about in the example here GPT-2, GPT-3. GPT-3 was the latest architecture language model that has 10 to the power of 20 amount of embedding space that was created for managing it. The immediate predecessor of that is the GPT-2. Here in this example, we're going to use the GPT-2 as a model that is being provided by Hugging Faces for our utilization for free. So here what I'm planning to do is I'm going to generate a text based on a context information that I'm going to provide here. And what I want is I want the text to be generated for a maximum length of 30, and I want 5 different texts to be generated based on this. If I run this, I can first download the corresponding GP2 and have that configured. Once that is done, because I have to basically restart this whole notebook, I'm running it. Otherwise, you don't need to run. It will not download it if it is already downloaded. Um, so now currently, if you look at it, has using the GPT-2, it has generated these 5 different statements. No human is involved here. That's the beauty of it. Hello, I'm a language model. I am writing a new language for you. Nobody taught this. Okay, but first I would like to tell you about blah blah blah. Okay, and the second statement, I am a language model and I am trying to be expressive as possible. That's a wonderful match. I'm a language model, so I don't get much of a license anymore, but I'm probably more familiar with and blah blah blah. I'm a language model, a functional model. It is not me, it's me. I think here it goes a little funny. The last one is I'm a language model, not an object model, and it gives some details. So effectively, because it has utilized the context and the positional information, you can see the kind of response that you got. You can even write your film story from this whole language model generation, language generation as such. There are some crazy guys even done that as well. They are forming a film based on some random text being generated from the natural language processing as such. So that's the beauty of it. This is in terms of generating text generation. The next use case is text summarization. The text summarization comes in terms of you have large news articles that you are having, that you wanted to summarize and provide a short snippet of what is that news article is all about, so that you can think of clicking and reading, spending some time on that if it is really interesting and important. So how do we summarize? Till now it has been done manually, no longer required, where you can put that to a transformer can actually summarize beautifully for you. Now here is an example. There is a big CNN article here, and this article is being given as an input to this particular summarizer. So now I'm going to take and run this, and what it is going to do is this article, it will summarize to whatever length that we are talking about. The maximum length of 130 and min length of 30 is what is going to do to actually provide you a small context and summarize that whole thing and provide you the details. Now it is downloading. Once the download is done, it will be able to display the details there for you. So bear with me. In a minute, it should provide the details to you. Download has completed, and it is started working for summarizing the details. Wonderful. So beautiful. So this is a summary of maybe 130 word summary of what is there in this whole paragraph. That is what is done by the transformer. See how quick it is. It has got this and brought this summarizer, and you can make this model, and you can even train it for your own specific set of data set, and have that model being built and created and exposed as a RESTful API. So any of your company wish to utilize that, they can just use that RESTful API for their whole processing and so on and so forth. Okay, that is the summarization as such. The next is text classification. So the text classification is specially, for example, you have a context information or a paragraph that is available. You wanted to understand what is the context that it is talking about. Is it talking about, say, a business related one, or medical related one, or an educational related one? What is that conversation that it is talking about? That is what is done by using text classification. Let me run it so that we can save some time. Here what I'm trying to do is, so I'm taking the zero shot classification as the pipeline. I'm defining that as a classifier, and in the classifier I'm giving this text. And after I provide this text, and I'm giving candidate label, because it already know what is education, what is politics, what is business. It can actually tell, based on the text that you are passing, what what is the probability of this particular text is an education text or politics text or business text. And it will give you the response based on that. How, what percentage, what is the probability that this text is a specific one. Okay, so now if you look at, this is what, now let me just go here. Now if you look at the actual text that I wanted to process is, this is a session about natural language processing. Now the score says, from an education point of view, it is 78%. From a business point of view, it is only 16%. In politics, it is 0.05%. Okay, so let's trick this particular solution, where instead of giving proper details, let me just try to trick that one. So I'm going to create a new cell, and take this classifier, and going to give a completely different input, and see how is it going to respond back for me. So Mr. Modi inaugurated the chess competition yesterday. Let me try this. And now this is the one, and it says it has taken business, education, politics, and the business score is 0.5%, and education is zero point 0.2, and your politics is point 0.2. So if I change, Mr. XYZ owned the election successfully. So now XYZ won the election successfully. It still takes business as 0.8%, and education it's absolutely not a related one, and politics it is taking 0.03%. It's a very interesting one. Okay, so this is in terms of text classification, as is how you can actually apply there. Okay, the next important use case is in terms of translations as such, where here if you look at the pipeline that I'm using is translate English to France. Now if you have multiple language to be supported, you can add all the pipeline information. You could be supporting France, German, probably 100 different languages. You can specify that corresponding pipeline so that those models can be directly utilized part of your translation service. And the Hugging Faces will take care of which model to utilize when you are performing the translation as such for what you are doing. So now here, what I'm trying to do is I want to utilize English to France. When I execute it, and behind the screen, it has been provided as a very simple interface for us. Behind the screen, what happens is it takes and it processes that as a transformer and provides the corresponding data back to us in French. Let's see whether it is responding properly. It is downloaded and it has provided the response as this. This is the French. I have no idea whether it is correct or not, but that is what it says. Okay, so this is in terms of text translation service, as simple as couple of lines of code. Okay, as simple as very couple of lines of code. Okay, the next is question answering session. So for example, you have this could be a wonderful item in terms of question answering based on a specific context. So here I take a specific context, and from that context I wanted to actually ask a specific question, and it can actually understand the context and actually try to respond back to you. Here I have taken a very simple statement of my name is XYZ and I live in Istanbul. And if you ask the question where do I live, and it will understand the context and it will try to respond back to you properly. It should basically respond back that I'm staying at Istanbul. If it says Istanbul, it's perfect. So now if you look at, this is the input context that I've given, and Istanbul is the place he live, and it understood that where do I live, and it has responded back with an answer of Istanbul here, and with a 95% accuracy score, where with which it can come back. Okay, so the next interesting use case is in terms of text generation. We have looked at text generation before, and this is another example of a text generation, and there is an advanced version of a text generation is also available, where you have text to text generation, where you can utilize that for a question and answer kind of detail as part of this, and it can actually provide you the response as part of your response as such. So if I run this advanced text generation, it takes the question as part of the actual input as such, and it is trying to actually provide you the understood that this is a question in the whole context as an input, and this is the context it could actually understand it, and it is generating a text in terms of the answer to life, the universe and everything. What is 42 is the question that you have asked as part of the input itself. So it has differentiated that it is a question and it is a context, and based on which it has actually provided the corresponding answer, that answer to life, the universe and everything. So that's a beauty of your text generation as such. So there are many different use cases that you can do as part of the NLP as such. Now what we have shown is how you can actually start utilizing NLPs as part of your day-to-day programming and day-to-day application generations and so on and so forth. And even Hugging Faces has separate library in terms of chatting based solutions for and also has some solutions in terms of multiple languages as such. And because it is the advanced framework in terms of a natural language processing, and it is much faster than anything that you can think of, and you can utilize this for your whatever the architecture that you are working on, chatting solutions or sentiment analysis and so on and so forth. This is the one where you should actually target to utilize. Transformers are the one you should target to utilize it there. Okay, now coming back to our presentation. So the next thing is, computer vision based solutions. Till now what we looked at is only natural language based solutions. How computer vision is currently handled in terms of uh, from the processing perspective, and how transformer is actually utilized here. That is what we're going to look at it now. Now, the neural networks were the advanced features in the last decade, and there is a special type of neural network called convolution neural network, CNN. And the way in which the CNN work is exactly mimics how a human eye work. The human eye looks at a specific area of an image or a specific position of an image, and it is the same approach that convolutional neural network try to mimic to understand multiple areas of an image, so that it can actually understand, learn, and convert that to a learning as such. uh, the major use case that you will have in the vision perspective is image classification. I show you an image, you look at it, and you tell what is there in the image. It's a very, very basic use case in terms of image classification. And CNNs were phenomenally good, but the basic problem in terms of CNNs were like it is because it is images. The more the layer that you put in the CNNs, the more processing time it is going to take, and the convolutions and your drop off layers in between that you are having, it is going to create a huge running time for training and processing the images and so on and so forth. So in 2020 we are looking at NLP based solutions for transformers. The basic problem that transformer solves is, whatever the text that you have, it takes the context information for the text, and it takes the position information for the text while processing it, so that your natural language processing outputs are much much better. That is, and also it does everything in parallel. So these three things that it is doing beautifully, so that your natural language problems are much better. But the same concept they've taken and applied it for images. Now when you take an image, before you feed into a specific transformer, you cut this particular image into a multiple small pieces, and you create a positional embedding vector based on what position, what information is available, and also include a context information of whether it is top, right, left, and the context information of that particular image, and create a parallel processing for this images rather than text, and process them using the transformers. That is what is being achieved in 2020 by a Google researchers, and they had a very good success. So which is called vision transformers. This was a very state of the art. It was released only 2020. The research paper was released only in 2022 20. Now Hugging Faces they've taken, and they have also implemented vision based uh, model, so that the same process that you have done for the NLP can be achieved for images as well. So that is what vision transformers does. Now they provide the vision transformer similar to the same approach of pipelines and the models. So you can utilize the pipeline and the model for your image processing. And the basic use case that is being covered phenomenally by the vision transformers were the image classification. You have an image, you give the image, and it will beautifully tell what is that image is all about. Okay, so that is what. Let's look at the demo of it. So the actual code for this particular vision transformer is also shared already. If I just go back to the code, and I will just open this, and this is the vision transformer. Let me just go here, and let me just see whether I am connected. Well, let me reconnect again in the same collab. The first one is, once the connection is done, okay, I will just install the transformers first. I'm installing the transformer, and the vision transformers are available part of this transformer. There are two different uh, you know libraries are being provided. One is called vision transformer feature extractor, and vision transformer for image classification. This is the two images that are being taken. Two modules that are being available there. Okay, it is installed. Now let me import all the reference library, and now I have two images available here. Unfortunately, both the images have gone because the session was disconnected. So let me just try downloading some. So let me just um, yes, yes, Mali, go on.
Basically, you're saying now transformers are doing something, image classification, these things are better. But I heard earlier tensors are doing more faster than in image classification, all of these things. Like, I'm not clear on these, both like I have somewhere it's contradictory.
Yeah, so effectively, the transformers will also utilize. So the TensorFlow, PyTorch, Keras, all these are frameworks. Okay,
Uh-huh.
so using them, what you do is you will write a specific algorithm for performing some activity. Okay,
Correct.
using TensorFlow, using the same TensorFlow, you can write the convolutional neural network that I was talking about. The
Mm-hmm.
convolutional neural network is an algorithm. You can write it on the TensorFlow as the actual framework, and this algorithm on TensorFlow you can utilize for image classification. That is one.
Mm-hmm.
Similarly, you have another framework called PyTorch that is from Facebook. So you can same the CNN as the algorithm you can write using PyTorch also. Okay,
Mm-hmm.
it is an algorithm that you write using PyTorch and utilize it for your image classification, right?
Mm-hmm.
Like your CNN, the convolutional neural network, transformer is another algorithm.
Mm-hmm.
This is the latest algorithm, and you will be still utilizing the TensorFlow for writing your convolution your transformer algorithm for vision. Similarly, you will use PyTorch for writing the transformer algorithm for vision. So effectively, at the end of the day, when you try to utilize, it could be part of your TensorFlow framework or your PyTorch framework, you will
Mm-hmm.
utilize the transformers there. Hope it makes sense.
Yeah, after that's clear. The question that's adding to that, even
Yeah,
the storing and even matching might happen through
yeah.
tensor, so that it will be little faster. Something I heard like this, because
Yes, the
most of the time
yeah,
those are vectors.
yes. Tensors are like, you can imagine that that is a basic premise of all the machine learning algorithm. Like how we represent the data for the computers, it is like you can imagine that as a variable. So we are all familiar with the different data types in our programming languages. We have a data type called int. So if it is an int, it can store or integer value. If it is a string, you define a variable as a string, it can store all string values. Similarly, there is a data type called tensor. You just for us, I'm just simplifying the whole thing. So tensor as a data type, what the tensor will store is vectors, or you can imagine that as a matrix. So the tensors can actually store and process matrix much effectively. So majority of all the machine learning operations that we are talking about, where vector operation or pretty much a matrix operation. Because the tensors are much better equipped to process these matrix at a very very good pace, all the representation of images, text, everything we're going to convert into a vector or a matrix, and we all going to go work on matrix based operation that is nothing but tensors. As simple as that. I'm just giving you the base,
Understand.
so that's the basic
So
premise of it. Yeah,
can I conclude like the tensors are almost storing and processing the data, and
right.
these transforms are the real logic which is bringing the output.
Exactly. These are the algorithms. Yeah, these are the
Yeah,
algorithms. So you have
understand.
neural network as the high level algorithm structure, and neural network, under neural network you have different variances. We initially talked about something called recurrent neural network, RNNs.
RNNs.
These RNNs were mainly built is a special type of neural network for natural language processing. And even there you had a variance of the neural network which is called LSTM, that is for specific problem, long short term memory. And there is another variance was GRU that we discussed before. So these are some of the variances of the natural language processing algorithms, but all are neural networks only. Okay, that is one. The second type of neural network is a convolutional neural network that we were talking about it. And the convolutional neural network were specially built for image processing, because the way in which the CNN work is it mimics the human eye. How you see it is exactly how the neural network is also architecture is built, algorithm is built. But at the end of the day, either you will be using TensorFlow for creating this algorithm, or you will use PyTorch for creating your algorithm. So that is how it goes. And you consider that these CNNs, RNNs, and all these algorithms were like 10 years old. There is a new type of algorithm came which is called transformers. And these transformers are much, much better when it comes to natural language processing task, because all the old items did not considered, all the old frameworks or the algorithms had a lot of drawbacks. Now the transformer, because it is considering the positional and the context information, and it can do things in a very parallel way, which is much much better when you compare with the previous algorithms which are came up. Okay, so the transformers as such is only a group of algorithms, okay, under which you have multiple other variances as well. For example, to go back and show you that difference, the NLP progress as such, this diagram should help you actually understand where it is, where we are. Um, Here, this diagram we were talking about. This is the evolution of NLP models. These are language models that were there for a very long time. What we are looking at is this transformers. This came in around 2018-19 as a code. The paper was released in December 2017. The people started understanding the capability and how it works and all in 2018. And you have various variances of this available as BERT, Elmo, XLNet, and so on and so forth. These are some of the even more advanced features available there. So using these, where these language models were built. For example, you see GPT-1, GPT-2, GPT-3, all these came in the period of 2018, 19, and 20. GPT-1 was built only with attention. GPT-2 was built along with attention and a little bit of your context information. And GPT-3 was built with position, context, and your parallel processing. All are being included as part of GPT-3. That's how it has evolved for a couple of years. GPT-3, I think, was released around 2020 or 2021. I was not clearly sure, but it is all latest model, the latest language model, where this can be utilized for further processing. For the matter of fact, you can now go and utilize this GPT-3 language model for your chatbot, English based one. OpenAI provides this as an API. So whatever activity that you wanted to do, whatever that we looked at, were through Hugging Faces using GPT-2, you can consider. But if I want to use GPT-3, which is the latest advanced one, OpenAI provides that as an API, and you can utilize it part of your application. What is an advantage of it? If you are doing a context aware transactions in chatbot, GPT-3 would be much better when you compare to GPT-2. That is what the advantage of it. You can actually get the proper responses, or understanding context can be done much better in GPT-3. That is what the difference as such. Okay, hope it makes sense, Mali.
Yes, Prasanna, thanks. Really.
Okay, so now coming to our image search, let me just search say uh, a building, let's say building. Let's say I'm taking some image. Let me just take some image. So um, save image as, I'm going to call it as image dot jpg, and I'm going to just put it in the desktop. So let me go to the vision, and the first thing is I need to upload this image so that I can actually access that. So here it has opened. Oops, okay. That's it. Yeah, so let me just move this content desktop. So I'm having this image.jpg. So let me just take this, modify this image, and this is installed. This is installed. File name is image. And let me just display this. Yeah, this is the image that I downloaded. So I can open this image. Sorry, this does not. It is image. Okay, I'm opening this image, and I'm going to do. We have feature extractor and the image classifier. So first, the feature extractor basically utilizes this particular model, and the image classifier is going to utilize this particular model for the pre-trained model that it is going to use for the image classification. First, the model is getting downloaded. So once it is downloaded, so now I can actually use that feature extractor and the model for my processing. Now the image that I have, the image array, that I will give this part of the feature extractor, and the input that goes to the model, and the output gives us a largest, and this largest I will get the class, and I will get the class and display the details. Let me just do this, and the output came, and the position of the class id of the output, and the predicate class is it is saying lakeside, and it is saying it's a lakeside. I don't know where I saw this lakeside. It is classifying this particular one as a lakeside. Okay, let's say basketball. Let me say basketball. Let me just take okay, so let me just take this image. Let me save images, uh, image one, jpg, desktop, and going back here, let me just content, upload, image one. Yeah, let me just go back. Image one, file name, display the file name. Yeah, I got this ball. Let's see one, and let's process it. Let's see what is happening. The class is 4:30, and what? Yeah, it is beautifully predicted that it is a basketball. So this is specifically how a transformer is utilized as part of the image classification task asset. So that gives an example, a high level overview of how NLP and your vision activities can be done directly using transformers as such. So any questions, team? Any questions?
Nope.
No,
Okay, wonderful.
Prasanna.
Yeah, fantastic. And as I said, OpenAI has this GPT-3 being provided as an API. You can actually access it, and you can start utilizing them part of your project that you're building as such. Okay, which is a very very powerful process. More than image processing, you can utilize the GPT-3 for your natural language, processing based requirements as such. Okay, so if there's no questions, I would thank all of you for patiently listening to this. I hope you guys enjoyed the whole session, and you know um, thank you very much for joining. Wait for the next session next week. Okay, thank you very much.
Thanks,
Really,
Prasanna.
Thank you.
Thank you,
really.
Prasanna.
Yeah,
Very
Thank you so
nice.
much, Prasanna. Have a
thank you.
good day.